the recap means it's like I'm talking about all the key points, right, of each topic again over here, right? So it's like call it grand summary, if you will, right? Call it a grand summary of all the topics for this term, right? You see, I can feel a cough coming now, right? Okay, I'm back. Okay, anyway, yeah, and as mentioned before, this session will not be recorded, right? And there's only one broadcast, okay, right now, okay? There's no repeat broadcast. So stay tuned, and I hope you guys are prepared to take down some notes as well, all right, as we go along. Okay, let's move on to my next slide. Okay, I think my laptop is kind of like influenced by my brain activity right now, right? Things are a little slow there, and laptop is also behaving a little slow. After a while, the things that you use will kind of like develop some behaviors that are quite close to you, right? Okay, anyway, right, I have the screen in front of me now. Okay, guys, so the same thing as in any online lesson. You have any question, please turn your mic on, right? Just turn your mic on and start speaking. Okay, don't have to wait for any break. I don't think that you need any break, right? And don't wait for the end of the session, right? For Q&A session. Of course, I will leave some a little bit of time at the end if you got any question. But when you have any question, any clarification, or you think certain things I'm speaking does not make sense to you, at that point, please turn on your mic and start speaking. All right. So don't wait until the end. Okay. Right. So let's go. Okay, first of all, of course, this all important slide again, right? I've shown you guys these at least a couple of times during the semester. So what we are doing next, what you guys are doing next is semester exam, right? So get it right, SEM, semester exam, right? Yours is an exam. Yours is not a test. So yours is not going to be EST, right? Yours is going to be SEM, semester exam. Anyway, you're preparing in the same way. So it has a weightage of 50%, which means that if you score 100 marks, you get 50 marks added to your cumulative marks, right? So your cumulative marks I've been showing you guys during the tutorials last week. Okay, that is including your CA2 results. Okay, 50% weightage. So that's a big deal. If you think you have done quite well, this 50% is going to get you even better, right? So maybe you can aim for a distinction or something, right? But if you think you have not done well enough, well, this 50% is going to help you a lot, right? So take full advantage of this 50% weightage, and nobody should fail, right? Because of that, right? So imagine if you get 60 marks out of 100, right? 50% is 30. So you get 30 added to your existing cumulative marks, which could be 20 something, 30, and you pass, right? Of course, you don't aim for that, aim for higher. Okay. All right. So 3 sections once again. Not that I've not mentioned before, but this exam paper is going to have 3 sections. Section A, MCQs, answer all the 10 questions, right? 10 MCQs. And section B would be short questions. So how short is a short question, right? So usually for each question, it is can go up to about half a page. So some people have big handwriting fonts, may take up to about 3/4 page. So something like that, right? It should not take you the whole page. You shouldn't have to fill up things that occupy the whole page. Of course, if there's a sketch involved, your sketch may take up half a page. You would like to sketch big, right? Okay. Right. So section B, short questions, 6, choose 5. Right. There'll be 6, choose 5, and each of 7 marks. So you get a total of 35 there. Section C, right? That will be your extended type of questions. 4, choose 3. Right. Each 15 marks. So extended question can fill up the whole page, right? If you want to, right? If you should, right? So don't be afraid to fill up the whole page, and including your sketch, right? Some may even spill over 1 page, right? But generally, I think 1 page should be enough to for you to answer your extended questions. Okay, which means that there could be a subsection, right? Usually there will be some subsection A, subsection B, and sometimes there could be subsection C, right? Even for section B short questions, there could be subsection A and B, right? So whatever it is, do not forget all the subsections. So make sure you answer subsection A, B, and C if there's a C, right? Or if there's a D, don't forget about D as well. All right, so every subsection carries some marks, and every single mark is valuable, all right, at the end of the day. Okay, any question on that? Okay, otherwise, let's move on. Okay, here. Let's start with this sample question. I called all these questions here sample questions. Okay, a coupling bolt with a cylindrical body and a slightly tapered forward end for easy entry is called what? Right? We've seen this more than a couple of times already, especially if you've been doing your weekly quizzes, right? So let's see, what is this all about? Answer, is it a small taper bolt? Is it a tapered bolt? Is it a parallel shank bolt? Or is it a medium taper bolt? Okay, so let's see where to find such an answer, right? You should have found it already, right, by now, if you have answered your quiz. Okay, parallel shank bolt, that's where it is, right? So this in your slides, shanks are parallel and cylindrical, right? Shank. So where's the shank? This is the shank, right? Right, the main part of the bolt, right? The body of the bolt. So that's the shank. Okay, so this part is cylindrical. When something is cylindrical, all the sides are parallel. So that's why it's called a parallel shank bolt, right? So of course, the answer is parallel shank bolt. Okay, this one, nothing too confusing about it, right? Okay, the only thing confusing is this question, the part here where it says slightly tapered forward end. Slightly tapered forward end. That's not the cylindrical body, right? So we're talking about the cylindrical body itself. Pay attention to the cylindrical body part, right? Okay, next, what contributes to stresses in a propeller shafting system? Okay, now when you read the statement propeller shafting system, is basically almost the entire shafting system, right? So that's what we have covered at the beginning of this term 2, right? So tail shaft or propeller shaft is subject to all these things, right? Torsional stresses due to the rotation, bending stresses, compressive and tensile stresses due to going ahead or going astern, right? And all these stresses could be fluctuating in nature, right? Plus, minus, a little bit up and down, right? Okay, so that's a tail shaft, propeller shaft, and intermediate shaft also almost the same thing, right? You have compressive stresses, tensile stress, torsional stress, bending stress, almost the same. Okay. And during operation, all the whole shafting system is experiencing a mix of all these stresses happening. Two or more could be happening at the same time due to the way the ship behaves in the ocean, due to the effects of weather, due to the effects of the wave, the current, the swell, or maybe it hit a few, dolphins along the way, hope not, right? Or, the ship gets entangled in some seaweed or what. I don't think so, but then you know what I mean, right? So maybe hit a few pirates, but then again, things do happen, right? So all these stresses could be happening at the same time, right? Or could be happening very, very close to each other. Okay, so the whole shafting system is always experiencing complex stresses, with different stresses happening at the same time or over a short period of time, right? And it could be worse, could be happening the same number of stresses continuously over a longer period of time, which makes things even worse, right? Okay, so everything here, right? Everything, almost everything here, okay? So basically, it's a multitude of stresses, okay? All right, so you get that, right? So it's not just one, it could be two or more different kinds of stresses or forces, right? All these stresses come from all the various forces. Okay? Some forces are mechanical, some forces are nature. Okay, that's it. The next one is the main function of reduction gears. Right? We've done that this term also. That's probably one of the shorter topics, right? But quite a bit of stuff there also. But you need to know by now, right? What is the purpose, function, purpose of reduction gears? So there you go, right? In your slides. Big header there, right? In your slides, function of reduction gear or gearbox. So it is to step up or step down the prime mover output speed so that the driven equipment could be run at the optimum performance. Right? Big bold statement there. So don't forget, it could be used to step up or step down the prime mover output speed. Right? Prime mover is the main thing that turns something, right? So you can change the speed. All right. Of course, here we are mainly talking about rotational speed, right? So the RPM. So you can step up or step down, okay, depending on what is the final use of this power coming from the prime mover, okay. And why you need to do that? So that the driven equipment could be run at the optimum performance. This is the all important statement, right? So that the driven equipment could be run at the optimum performance. That means the driven equipment operates best at a certain RPM or a certain range of RPM. So that's what the reduction gear does, right? Between the prime mover and the driven equipment. Okay. Okay, some examples below, which I'm not going to elaborate now, right? I've done that during the lesson on this topic. All right. Okay. So just to stress that that is an accurate statement. All right. Okay. So you guys hope you're taking notes. Right. Okay. Next, an intermediate shaft bearing typically provides bearing surface to what extent of the intermediate shaft, right? Intermediate shaft is this intermediate shaft with the bearing holding it, right? So it provides bearing surface to what extent of the intermediate shaft, right? Again, gone through this at least 2-3 times already. In fact, this was covered over 2 topics. So is it the lower half of the shaft circumference? Lower half, all right? Or is it the upper half? Or is it the lower 1/3? 1/3. 1/3. or is it a complete shaft circle, right? So read the question, intermediate shaft bearing, right? Okay. So of course, you will find this in your notes, right, in your slides. Intermediate shaft bearing or steady bearing support and keep intermediate shaft from misalignment, and bearing surface of white metal provided only in the lower half. In the lower half, all right? So which means, there you go, right? Lower half of the shaft circumference. Lower half, shaft circumference of the intermediate shaft. So only the lower half, all right? Okay, let's go on. How is a propeller secured and prevented from rotating on the tail shaft, right? Just talk about this the last 2 weeks. How is a propeller secured onto the tail shaft, right? And prevented from turning around the tail shaft. Okay, I've talked about this more than a couple of times. Okay, in your notes. So is it by friction grip? Is it by a pilgrim nut? Is it by a key? Definitely not by a pilgrim nut, all right? So propeller held in place by friction grip, and a key may be included in some cases, okay? So it's either or, right? Whether friction grip itself may be good enough, or maybe a key is added, right? Or maybe, you know, both got to act together to prevent the propeller from turning, all right? Okay, so it's and or, friction grip and or key, right? Okay, so it's either one, right? Either and or, okay? And or, okay? And/or. Okay, let's see. Now, John Snow say you can't see anything, not so sure, right? So the rest can continue to see things, right? Can continue to hear me, right? All good still for the rest of you? Okay, thanks, Zafan, Marquez, and Adriana and Wei Ming. Yes, okay. So I'm not so sure what happened with Jon Snow. Whoever that may be, right? You guys know who is Jon Snow? Okay, anyway. Is that the Jon Snow from Game of Thrones, right? Okay. Hopefully, Jon Snow can get back soon. LMAO. Okay. Okay, anyway, let's move on. Okay, next, what is the function of the truss block? Function of the truss block. Again, it's all in the slides, right? Function of the truss block, to accept thrust produced from propeller and distribute it evenly to ship structure. I think if your fonts are not too big, this is just a one-line statement, right? To accept thrust produced from propeller and distribute it evenly to the ship structure. So accept thrust, or you say receive thrust, fine, right? Distribute evenly to the ship structure. That's very important, so that the thrust does not end up in the main engine. Okay, so that's an easy one. Next, what type of bearings uses the hydrodynamic lubrication type of lubrication, right? Using the hydrodynamic lubrication type of lubrication, or the method of lubrication. So I've touched about it, and I've also included a video on hydrodynamic lubrication, right? remember this fun guy, right, talking about bearings and hydrodynamic lubrication and bush bearings, right? I also included these in your bright space. So these A is roller bearings, B ball bearings, C bush bearings, right? So A and B, not really, right? They don't use that much of, basically they use rollers and balls, right, to move, to rotate. But for C, you are going to use hydrodynamic lubrication, right, to lubricate. Okay? So definitely, right, bush bearings. Okay. So C, bush bearings. So bush bearings uses hydrodynamic lubrication as the key method for lubrication. Okay. The stern tube is a bush bearing, right? So stern tube uses bush bearing. Crankshaft uses bush bearings. Okay. Okay, what type of force should not act on the crankshaft? Again, this is for you to read carefully, right? What type of force should not act on the crankshaft? You know the crankshaft has a lot of forces, right? But which type of force should not act on the crankshaft? Is it the thrust developed by the propeller? If allowed to act on the crankshaft, it will critically damage the crankshaft. How does that statement sound to you, right? Now, the propeller's thrust force must be transmitted to the ship's hull through the thrust block. All right? Crankshaft. An engine crankshaft is designed only to handle the forces, as in this diagram here. Right? Forces from the conrod, twisting of the crankware, bending of the crankpin, bending of the crankware, torsion on the journal. Right? So that's what the crankshaft needs to deal with, all these 5 types of forces, but not the thrust force coming from the propeller, which must be redirected downwards to the ship's hull through the thrust block. All right? Okay. So it is a thrust developed by the propeller or the thrust force from the propeller. Okay. So to answer more accurately, it is a thrust force from a propeller that should not act on the crankshaft. Otherwise, the crankshaft is going to be critically damaged. Okay. Right, next, what is a key advantage of a ship's bow thruster? Key advantage of a ship's bow thruster. Okay, so of course there are more than a couple of advantages, but let's look at your notes, right, on thrusters. Why the need for thrusters, right? So bow thruster or sometimes stern thrusters, they're fitted to cut down on requirement of tugboats, or you could even dispense with them totally, right? Don't need them, especially if you have both bow and stern thrusters. And why do we need tugboats in any case? Tugboats are required to shift the ship sideways, right? When the ship is berthing or unberthing, right? The ship's propeller can't move sideways, can't move the ship sideways. All right. Okay. So key advantage of ship's bow thruster. All right. Okay. Next, international requirements, mandates. Mandates means is a compulsory requirement, right? International requirement mandates that a ship's steering gear shall be capable of doing what to the rudder? Doing quite a few things, but it should include at least one of these things, right? Again, in your notes, right? The main steering gear must be able to turn the rudder, right? Must be able to turn the rudder from 35 degree on one side to 35 degree on the other side. At the same time, it also must be able to turn the rudder from 35 degrees on either side to 30 degrees on the other side in not more than 28 seconds. Okay. The first requirement is 35 to 35 at maximum speed and deepest draught. Okay. It also must be able to turn 35 degrees on either side to 30 degrees on the other side in not more than 28 seconds. 35, 30, 35, 30, and 28, right? 35, 30, 28. 35, 30, 28, right? That's your, what I call that? Whenever key something, you receive an SMS or something, right? So what do you call that thing? The 6 digits stuff. Okay, Bryce is earlier, a little while ago, Bryce asked me to go back to the previous slide. So maybe Bryce, are you okay, or which slide do you want me to go to? The one before bush bearings. Okay, let me do just that. Okay, I'll come back to this steering gear rules quickly once again, right? So before bush bearing, okay, before bush bearing was this slide, right? So function of the truss block, right? So what's the function of truss block? The answer is there, right? In your slide, function of the truss block to accept thrust produced from propeller and distribute evenly to ship structure. Okay. Right, I get it. Sometimes you guys paraphrase a little bit, right? When you paraphrase, the paraphrase sentence must have the same meaning, right? You must identify the required parts or components, if there are parts or components in it, and it must sound the same. It must provide the same meaning as what it should be, right, in your notes or in your slides. Okay, so must have a similar meaning. Okay, you can paraphrase: to accept a thrust produced from propeller, or to receive thrust. Well, accept, receive. No issue with that, right? But it has to be a thrust, and you want to add thrust force. That's fine, right? Produce from the propeller, or instead of from, you say produced by the propeller. Well, that's fine too, right? To accept thrust produced by the propeller and distribute evenly to the ship structure, right? So distribute evenly to the ship structure. I'm not so sure that if you have another way of explaining that or paraphrasing that, but otherwise, this statement itself is, I think, is simple enough. I don't think you can even shorten any more. Okay, all right. So I hope this is the one that Bryce is talking about. Okay, and Owen say basically an anchor. I'm not so sure. What do you mean, Owen, when you say basically an anchor? What are you referring to? Truss block. Oh, okay. I think you missed the deck machinery in term one, right? Anchor is something hanging at the bow, right, on both sides, port and starboard side, the anchor. And what does the anchor do? The anchor is to hold the ship, right, in a certain location so that the ship does not drift away, right? You get what I mean? To hold the ship in one location so the ship does not drift away, right? So there's a anchor. You drop into the seabed, drop onto the seabed. Truss block, where's truss block? Truss block is just near the engine, right? Near the main engine. Truss block is in the engine room. Okay, so anyway, Owen, I think you got to truss block. Oh, you say truss block anchor the truss produced by the shaft. Well, I think you can't use the same way of explaining, right? Anchor, to anchor something, right? Okay, here you want to distribute the force evenly to the ship structure. You're not going to anchor it. Anchor means something is not moving. But the truss block is what makes the ship move, either ahead or astern, using the thrust from the propeller, right? So you want the ship to move. So you say anchor means nothing is moving, right? I anchor myself onto this nice chair here for the next 1 hour. So I anchor myself here, not moving for the next 1 hour, right? So that's not the job for the thrust block. The thrust block is to move the ship. Okay. Okay. All right. So don't use the word anchor. You say anchor. You say the thrust block does not move with respect to the ship. Yeah, of course, the thrust block does not move. Right. That's what you want it to do. If the thrust block can move, then all these components, the ship's shafting system is moving all over the engine room, right? So definitely it does not move. But you need a thrust block to move the ship. Okay? Without the thrust block, the ship is not going anywhere. So, in other words, if the thrust block has a problem, the ship has a very, very big problem. Okay, that's why thrust block, they are closely monitored, right? When the thrust block temperature is going high, very, very urgent attention has to be given, right? Something is really wrong, right? When the thrust block temperature goes too high, the truss bearings inside will get burned, and when the truss bearing gets burned, that's the end, right? Because when truss bearing get burned, or the truss shaft itself will get burned, right? When that happens, you've got to stop running the ship, right? Running the shaft. If you stop running the shaft, the ship is not going anywhere, and that's a huge, huge problem. Okay, so that's why thrust block is a very sensitive equipment. The ship's thrust block have a problem, the ship is not going anywhere. All right. Okay, but you can't say anchor, right? Then everything else on board the ship is also anchored, right? The ship's stove is also anchored, right? But we don't want to say that, right? It gives a bit of confusion there. Okay, I know where you're coming from, Owen, but choice of words sometimes will happen at the right time. Okay, I get what you mean, Owen. I hope you get what I mean too. Okay, anyway, let's. I hope that's good for Bryce, and let's move on. Okay, functional thrust block. Okay, bush bearing. I think we've done that already, right? Okay. Thrust force from the propeller should not go to the crankshaft. Okay, key advantage of bow thruster, we've done that also, right? Okay, we were talking about this, right? International requirement mandates that the ship steering gear shall be capable of doing what to the rudder, right? A few things, out of which one is to turn the rudder 35 degrees from one side to 35 degrees on the other side at the maximum speed ahead and deepest draft, right? And the other requirement is from 35 degrees on either side to 30 degrees on the other side in not more than 28 seconds. Okay, here the choice of words will be quite important. You need to state from 35 degrees because that gives you a sense of relativity there, that something's going to move away from a certain position, right? So 35 degrees on either side, can be this side, can be this side. I'm talking about the rudder, right? So 35 degrees from the center line, right? Center line, of course, is the midship position, which is 0. So I should say from 35 degrees on either side. Either side can be from this side or from this side, right? So that's the correct choice of word. 35 degrees on either side to 30 degrees on the other side. So don't say 35 degrees on the other side to 30 degrees on either side. The story is totally different, right? Here you're telling a story, okay? From 35 degrees on either side, could be this side, could be this side, to 30 degrees on the other side. And don't forget about the timing, in not more than 28 seconds. Okay, so this is your OTP, right? Yeah, that's your OTP, 35 30 28 353028, right? 35 30 28, that's your OTP, right? Okay, for steering gear at least, and it's not going to change, right? It's like a permanent OTP. Okay, right? Any question on that? Okay, moving on. Okay, the background color has changed a little bit, right? So let's do this. There are two sub questions here, right? Why is alignment of shafting arrangement very important? And the next sub question is state 3 shaft alignment methods. So this goes back to the first topic of the term 2. Okay, here in this particular slide here. So okay, you got this page here, shaft alignment importance. Why is it important? Because the ship structure that the shafting system rests on is regularly experiencing a combination of hogging and sagging effects, loading condition, draft conditions, wave conditions, right? So because of all these 4 items, they are creating stresses on the shafting system. All kinds of stressing, hogging and sagging stresses, loading conditions, stresses, draft condition, wave condition. So the shafting system is being twisted around, bended, being bent up and down, right? Torsional also. Just have to take a sip there. Okay, so all these things, right? All these things is why shafting alignment is so important, or alignment of the shafting arrangement is so very important. Okay, so of course you can paraphrase all this, right? That's how it means the same thing. Okay, got a bit there. So yeah, you just have to practice. Okay, and all this point form stuff is helpful, right? Okay, next, the excuse me, 3 shaft alignment methods, right? In the next slide. Okay, either one of these is a method, right? So piano wire is called a method, micrometer is a method. So I mean, for this chapter, we treat it like this, right? Piano wire is a method, micrometer is a method, feelers between coupling faces is a method, optical method is a method, laser method is a method. So if you want to know, want to state 3, either of these, either 3, any 3. All right, any 3 of these. Okay, so it's straightforward. All right. Okay, any question for this slide? Okay, next, what is the difference between fixed pitch propeller and controllable pitch propeller? Quite a bit of differences there, right? What is the biggest difference? There's one big statement, right? And of course, don't forget subsection here, least 5 advantages of CPP. Okay, the difference between fixed pitch propeller and controllable pitch propeller. Okay, is right there in the notes. So the blade angle of a fixed pitch propeller is fixed and cannot be changed, while a blade angle of a controllable pitch propeller can be changed and controlled by means of hydraulic mechanism, which is generally positioned within the shaft and hub of the propeller. All right, there's the whole statement there. The main difference between a fixed pitch propeller and controllable pitch propeller. Okay, here is the main difference, not the way they are operated, right? Here the main difference. Okay, the blade of a fixed pitch propeller is fixed and cannot be changed, which is straightforward, right? While a blade angle of a controllable pitch propeller can be changed and controlled by means of a hydraulic mechanism, which is generally positioned in the shaft and the hub of the propeller. Okay. 5 advantages of CPP. 1, 2, 3, 4, 5, 6. There are 6 here. Okay, but any 5, right? So one of the advantages is it can control 0 to 100% any desired thrust. Non-reversible engine of less weight can be used compared with heavier, large, short-speed reversible engine used for fixed-pitch propeller, right? So CPP can use a lighter, non-reversible engine. Okay, and a lighter, non-reversible engine usually is a smaller engine. Smaller engine could be a medium-speed engine usually, right? So lower cost also, or cheaper medium-speed engine can be used, right? Blade can be individually replaced. Of course, that's one of the very important differences, right? Blade can be individually replaced for CPP. Engine required to be started only one time, which is quite true, right? Engine for CPP, you start the engine, even if it's coupled to the CPP can be turning, but the ship is not going anywhere if the CPP blade is all at 0, right? 90 degrees cutting through the water. So ship is not going anywhere unless you turn the angle of the CPP, right? So engine can be started one, which is a advantage because you don't have to keep starting, stopping the engine during maneuvering, and need a lot of compressed air to kick the engine each time. Okay, and of course you have one at the bottom there. In case of power failure, controls will move to full ahead. So why is this called an advantage, right, for CPP? Because if there's a power failure, blackout or whatever, the blade can move automatically to the full ahead, because remember, if the ship is not moving, the rudder is useless. So if there's a blackout on the ship, you still need the capability of the ship to be able to steer port or starboard, right? So they can steer away from any potential collision, right? So if the ship is moving, just drifting, then the ship is not be able, you can't steer the ship, right? So at least with a little bit with some power there, where the ship is still moving in a head direction, this thrust force, right, from the propeller can be directed to the rudder to turn the ship, right, to the port or to the starboard. So the ship can be steered away from any danger. So because of that, that is an advantage. All right, so any of these 5 advantages. Okay, question? Okay, next. What is a clutch? Again, one of the shorter topics, right? And sub-question, name 2 types of clutch and the equipment each is used for. All right? One second, I just want to get out from my phone. Okay, so clutch, again in the slides. Right? A clutch is a mechanical device which allows the operator to control the drive and driven shaft to be engaged or disengaged. Drive and driven shaft to be engaged or disengaged. Engaged or disengaged. So the choice of words is quite limited here. Engage and disengage. Right? So that's the technical terminology. You engage the drive shaft to the driven shaft, or vice versa, right? And you disengage the drive shaft from the driven shaft. Engage to, disengage from. Okay, right? Okay, a bit of English there, but not easy to find a replacement word for engaged and disengaged. All right, so try to use these same words. All right, so two types of clutch and equipment that is used for. Right, two types of clutch again is in the same slide. There's the first answer there. What is a clutch? Second answer is there. So you got multi-plates or multiple plates. You heard me say multi-plates, right? That's fine if you choose not to write multiple, multi. I know that you're right, referring to multiple. So multiple plates or disc, multiple plates or multiple disc clutch. There's one kind of clutch. Centrifugal clutch, there's another type of clutch. Dog clutch, slip clutch. So those are the four types of clutches there. And each of these clutches, they are meant for what type of equipment, right? So multiple plates, this type of clutch, they are meant for main propulsion, basically, main propulsion gearbox. Main propulsion gearbox. Centrifugal clutch usually used for purifier, means centrifugal separators, right? And air motors, right? Air motors. Okay, air motors sometimes call it pneumatic motors, right? You use compressed air to turn something, right? So that you can power a winch, a small winch or something, right? Okay, dog clutch used for deck hydraulic winches. Dog clutch is the simplest, right? Just one side is like this. Let's say I have four protruding jaws here. I got five, not four. Five here, five here. So they are all the same shape, profile, and size. So they intertwine against each other. They turn, right? So there's a dog clutch. Commonly used for deck equipment, like windlass, winches. Slip clutch used on marine propulsion also, right? Yes, I have to clear my throat again. Okay, guys, all good here? Okay, yeah, so any two, if you are required to name two, okay. Okay, so quite straightforward there. Okay, what are the three problems of intermediate shaft bearings? You know there are three. No two, it's not two, not four, but three, right? Very uniquely three. Three problems of intermediate shaft bearings. And read the whole statement, right? Include one possible reason for each problem. So you know there's a problem, there is a reason. One problem, one reason. Each problem could have more than one reason, but you're required to state one reason for that problem, right? So three problems. Okay, again there in your slides, 2 pages there. Problem associated with intermediate bearings. Number 1, lubrication failure. That is problem number 1, lubrication failure. And there are several reasons. 5 reasons there. Could be insufficient oil, contaminated oil, incorrect oil, failure of lube oil supply mechanism, could be cooling water, too much or too little. Okay, so just include one of those, right? Lubrication failure with insufficient oil or contaminated oil or incorrect oil or failure of lube oil supply mechanism or cooling water issues. All right. Okay, and second problem is overloading. Overloading. And overloading is caused by misalignment. Due to what reason? The main thing of overloading is usually caused by misalignment. And the reason for misalignment could be a local fire or grounding of the ship or normal extreme sagging, hogging of the ship as the ship goes through the ocean, right? Thermal expansion and contraction. I think those of you who attended the class, right, the lesson of this, I've explained that what's the meaning of thermal expansion and contraction, or weakening of the house structure. Weakening of the house structure where the intermediate shaft bearing sits on due to aging, right? Corrosion sets in, a little bit of hull damages in between. It makes the whole ship structure underneath the intermediate shaft bearing a little weaker over time, right? Okay, so overloading is the one problem. Okay, it is caused by misalignment due to the following reasons. One of them, right? You've got to include one of them. Okay, the third problem, metal failure. Okay, metal failure, right? Third problem, metal failure. What is the reason? Fatigue caused by vibration and corrosion, right? Metal failure caused by fatigue. Again, reason is vibration and corrosion. Of course, that's over a long period of time, right? That means you have fluctuating stresses, right? Of both fluctuating vibrations, stresses, and corrosion. Corrosion means things become weaker and weaker. Here we are talking about metal failure of the intermediate bearing itself. All right. Okay, so there you go. Right. 3 problems and include one of the possible reason each. And of course, with number 3, there's only one reason anyway. Okay. All right. So those things there anyway in your slides. Okay. Next, state any 4 types of checks during steering gear test. Steering gear test, if you go through the steering gear test procedure, which was covered in last week's topic, right? Steering gear. There are many checks. I've included a video also, right, of a junior engineer going around doing all those checks, right? With some lively music in the background, right? So many checks. Of course, there could be like more than a dozen checks, right? But here, if you can state just 4, okay? And the other sub question there, list any 3 disadvantages of rotary vane steering gear compared with 4-ram steering gear. And those are the 2 main different types of steering gear system, right? 4-ram or ram system, right? And the rotary vane system. Okay, testing of steering gear, you got a list there. Not more than a dozen, but good enough for you to pick 4, right? Any one of these, okay? Steering gear test should be done within 12 hours before departure port by the ship's crew. Visual inspection of the steering gear and its connected linkages, that's one item. Next, check levels of hydraulic oil pumps and reserve tank, one item. Test communication equipment between navigation bridge and steering gear compartment, another item. Test power unit failure alarms. Test full movement of rudder from port to starboard and vice versa. Full movement is the 35 to 35, right? Check the rudder angle shown at the steering gear local rudder indicator or rudder angle indicator correspond with the remote indicator on the bridge. Okay. Test a few random position, right? Test manual control of the steering gear locally and from the navigation bridge. Okay, manual control. All right. Okay, so any four. And the next thing here is the rotary vane steering gear. Disadvantages: low reliability, wear and tear more. We can't take any vertical movement, right? A little bit of vertical movement, rotary vane, the steering gear will get damaged. Seal failure is right. Not right. Seal failure rate is high, right? So there's a lot of seals inside the rotary vane. Any seal failure, you can't notice it, but you just see a drop in performance, right? And there's seal failure is quite high. That's why every dry docking, the rotary vane system got to be completely dismantled and check the seal and replace the seals. Okay, because failure you can't see, right? Failure of the seal, and they will be high because there's a lot of wear and tear. Okay, so any three of these, all right? Okay, pretty straightforward, right? Okay, just give me a couple of minutes, right? Uh, I need to take a little break here, but don't go anywhere. I'll come back in a couple of minutes. At the same time, I'm going to grab my power supply. All right, so don't go anywhere. Stay tuned. Right, I'll be back before you know it. Right, so just stay there. Okay, I'll be back. So you got to really start with nut first screwed on till flush against the propeller boss. Nut means the pilgrim nut, right? I mean, you say peanut, right? Peanut, that's fine. I know you're referring to pilgrim nut, right? Okay, so nut first screwed on until flush against the propeller boss. Here, flush against the propeller boss. Hydraulic connections made, right? Hydraulic connection here made. Pressure raised as per specifications. As per specifications of the manufacturer, okay? Loading ring inside here, loading ring will exert a push which pushes the propeller up the taper of the shaft, up the taper of the shaft, right? There's no simpler way of describing that action, okay? Loading ring will exert a push, right? Which pushes the propeller up the taper of the shaft. Then when propeller is tight and has traveled the required distance up the taper, that means the propeller will move slightly to the left. If it has traveled the required distance, required distance is as per specification. Once it's done that, the hydraulic pressure can be released. All right. Then boss grips the taper by friction grip. Nut tighten and lock. That's it. Okay. Okay, so that's it, right? Those are the 6 steps there. You can't miss out any one of them and you can't jumble them up. It has to be in that sequence, in that order. All right, guys? Any question? Okay, pretty straightforward. I just need to practice. All right. Okay, next. Okay, let's look at the Hui Xian is asking something. Must I draw the diagram along with the written answer? Diagram. I think I take it that Hui Xian is talking about the pilgrim nut diagram. Right? How do you use a pilgrim nut method to secure propeller onto the tail shaft? If that's what you are meaning, no, not really, right? I mean, you can, but then, I mean, if you sketch here, right, this thing here, it might help you, right, with the sequence, right? But if you already have this in your mind, right, you're already projecting this in your mind, that you can come up with the sequence correctly as well, right? So, okay, I can only say not really, right? If you are talking about whether do you need to sketch this, I would say not really. You can, but you don't have to. Okay. You can include also if you have time, but you don't have to. Okay. You should already have a clear idea of this in your mind. All right. I'm not stopping you guys from sketching this. Right? Of course, you want to sketch anything, make sure you sketch correctly. Because if sketched incorrectly, probably you're going to answer incorrectly also, right? There's a high chance of that happening. Okay, I hope I've answered Hui Xian that question. Okay, name and describe 3 different constructional design features of crankshafts or main diesel engines, right? 3 different constructional designs. Okay, again, in your slides there, of course, first design is your fully built. Now, read the question carefully. Name and describe. It's not just naming. Naming means fully built type. That is naming one type, right? But I must describe also, right? So what is a fully built type? All 3 parts are fabricated separately and webs strung on the crank pins and journal. Webs are those flat pieces that are turning around, right? So the webs are fitted to the main journal, the journals, and the crankpin. Journal in the middle, and the crankpin that swings around, right? Okay, so all these three parts, web, journal, and crankpin, well, they're fabricated separately, and webs are strung on the crankpins and journal. Strung means strung fitted. Then the second type, remember 3 types, right? Second type is semi-built type. Semi-built, fully semi, right? Full, when we have full, you have semi also. So fully built, semi-built. In the semi-built type, you got to describe that the web and crankpins are fabricated as one unit. So the 2 web and the crankpin, they are fabricated as one unit, right? Okay, the web is 2 sides, right? The 2 webs and the crankpin, they are from the same piece of material. So that's what semi-built means, right? And then they are strung onto the journals. One journal here, another journal on this side. Right? This part here strung fitted onto the journal. This part here strung fitted onto this side. Okay, so there are 2 components basically. This whole thing is 1 component. This one is 2 components. Right? Different component. Okay, so that's semi-built. Okay, semi-built. And of course, the last type is one-piece crankshaft. One-piece crankshaft, usually drop forged as a single piece from a single piece of material, and it's normally used for high-speed engines. And why high-speed engines? Why is that? Because high-speed engines are small engines usually, right? So small engines which are like just maybe 2 meters long, right? Or slightly more than that. Okay, so these are high-speed engines, or maybe they are 3 meters. They are up to 3 meters. You can manufacture from a single piece of material, right? Drop forge and then machine to size. Okay, but anything bigger than that, you can't. You've got to choose either a semi-built or a fully built. Right, so fully built type, 3 parts are fabricated separately and web strung onto the crankpins and journal. Semi-built type, web and crankpins fabricated at 1 unit and strung onto the journals. Okay. Okay. Right, pretty straightforward. Requires a bit of practice. Okay, with a simple sketch, we're still on the crankshaft, right? With a simple sketch, illustrate the different forces acting on the crankshaft during operation. Simple sketch illustrate the different forces acting on the crankshaft during operation. How many forces are there? 5, right? There are always 5 forces. Okay, so the slides give you these, right? Okay, so here with a simple sketch, illustrate. So this one you can't illustrate without a sketch, right? So any sketch normally will also be accompanied by labels. So these are all the labels, right? All these directional lines, arrows, they are very important, all right? Okay, so how do you do that? I mentioned before, right? In class, you really just got to practice, right? Just practice, okay? Start with 2 shoe boxes. I call them shoe boxes, easier, right? Shoe boxes. angle, something like that. Okay. Two boxes, right? Maybe not so wide. Another one, just slightly behind here. Of course, freehand, right? So you want to join, make sure it's aligned with this line here also. Okay. This line also aligned with this. This line aligned with this. Okay. I have a little circle here. Then I join this here. So this is my crank pin, right? Okay, I have my journal here. Just draw a circle here and draw two lines. The line same direction as this straight lines here. Okay. And sketch with pencil, I can erase off this, right? That's called neat. Have to be neat. And since there's a journal here, the other end also I have a journal, right? So I just go along here, another line here, another line here. Okay. Right. So I already have my crankshaft for one cylinder. Okay. So I have one of the main forces coming down here. Arrow is important, right? And then there's forces from the connecting rod, right? Forces from the connecting rod. Of course, don't do this. Don't do this, right? In your answer, right? Full forces from the connecting rod. So when forces come down, these two webs will twist inwards in this way, right? So I'm going to illustrate that for one of the webs, the center line of the web here, right? I'm going to do this arrow here, right? Twisting of the crank web, twisting of the crank web right and full, right? And then there's bending of the crank web, right? Bending of the crank pin. Right? These forces from the connecting rod comes bending of the crank pin. So how do I illustrate bending of the crank pin? And just make something like a dimension line here, right? And I put an arrow here. Okay. Bending of the crank pin. Okay, again, right and full, bending of the crank pin. And then at this position, the crank webs are trying to bend this way, right? Because of these forces from the crank connecting rod, crank web will bend this way. So in order to illustrate that, I just make a dimension line here also, and then I put an arrow here. Okay. Bending of the crank web. Bending of the crank web. And finally, I have torsion of the journal. All right. Torsion of the journal. So I got my 5 forces there. Okay. So these took me about 2 minutes, right? This took me about 2 minutes. Okay. 2 minutes. You can do it in 5 minutes. I think that should be fine. Right? Okay. Again, I'm using here whiteboard marker on the glass board here, right? You guys practice pencil on paper, right? Okay. So it's all practice, right? Okay. Anyway, you've done that already, right? About 51 times. Okay. Right. So all these things, don't forget, right? No short form, right? Write them in full. Okay, that's how you do a simple sketch. It's not too difficult, a sketch. A simple sketch, just what to start with the right things to do. Then you don't miss out anything, and you don't sketch funny object here. So with two shoe boxes here, standing shoe boxes connected by toilet roll core, right? Inside the toilet roll, there's a crank pin, another two toilet rolls here. Those are the journals. There you go. There you got a crankshaft already, right? You can make this at home, right? Okay. And then don't forget to label them. All the arrows are pretty important. Okay. Okay, simple sketch, illustrate. Okay, no fancy description. So everything here, sketch and label. All right. Okay. Torsional vibrations in slow speed diesel engines are addressed by what? Using what kind of things, right? Torsional vibration, very simple, right? Answer is just vibration damper or detuner. Okay. Torsional vibration in slow speed diesel engines are addressed by vibration damper or detuner. That's all. That's one of the simplest answer you can answer, right? Of course, you can state, oh, torsional vibration in slow speed engines are addressed, but you can rewrite the question, right? Okay, by the way, that's what I'm looking for, right? Vibration damper or detuner. Okay. Okay, name the equipment below, identify the parts marked 1 to 8. Okay. Again, you have been doing this also, right? During your weekly quizzes. Of course, two parts there, name the equipment and identify the parts. Okay, two parts of the question there. Intermediate shaft bearing, of course, right? If you choose just to write intermediate bearing, fine. Yeah, that is correct as well. So number one is the housing, or you write casing, that's fine, right? Or you put a cover, it is fine as well. Sum, two. Now, do I need how remember the arrows, remember the number, to remember the parts, right? Go by the arrow, go right here. There's the oil sum or sum. Okay. Side glass, if you write it as a level indicator, fine as well. Level glass, that's fine as well. Right? Gauge glass, fine as well, right? They all mean the same thing. Number four has to be the drain cork or drain valve, whichever way, that's fine, but it has to have a drain there, all right? Number five, this is a special deflector plate. So you can call it just deflector, right? Again, spell correctly, deflector, not defector. No defector, it's deflector. Flag, listen the difference there. Defector, no, right? Deflector, deflect, deflector, okay? Not somebody who escaped to another country, that's called defector. This deflector, okay? Lubricating ring, nothing else you can describe. You can't describe it any other way. This one, no choice. You got to say lubricating ring. Well, if you short form it, that's okay. Loop ring. Oh, okay, I get it, right? Loop ring, that's fine as well. Number seven, intermediate shaft. Of course, don't forget your main thing here is the intermediate shaft. So don't say this is a tail shaft or anything else, or crankshaft or whatever, right? It has to be an intermediate shaft. And this is the white metal bearing, okay? So look where the arrow points to. The arrow points to this dark shaded part. So that has to be a white metal bearing, a white metal layer there. Okay, white metal bearing. Can't be anything else. So all these 8 parts here, right? Again, practice, right? Okay, describe how the lubricating mechanism works in the equipment in the previous slide. Previous slide was the intermediate shaft bearing, right? So that lubricating ring basically is what you are going to describe. Okay, again, in your slide. So everything there. Can paraphrase it, but must mean the same thing. When shaft rotates, lubricating rings gets rotated. You can say when shaft rotates, lubricating ring also rotates, fine, right? But the rotation of the lubricating ring carries lube oil to the top. Then you have to give me that impression, right? Rotation of the lubricating ring carries lube oil to the top. You can say from the sum to the top. And when the oil goes to the top, it is the job of the deflector to help spread the oil over the shaft and bearing. Okay, and you need not say splash lubrication. You can, but main thing is deflector. Don't miss out that part. Deflector help to spread the oil over the shaft and bearing, right? Then that's all you need. These 4 points, 3 in fact, right? There's these 3 points. The last point you need not include. You can include, right? But need not, right? So the method of lubrication basically is all there in the first 3 points. Okay. The last one, drain valve. You don't have to say. You don't have to say that. So just these 3 points, and that's it, right? Okay. Describe in another way as long as I get this whole picture, the same picture when I read it. That's fine. All right. But don't miss out the deflector. Don't miss out lubricating ring, right? Okay. Right. I think we're almost finishing soon. Okay. Identify the system shown below. Shown below. Okay. So of course, it's kind of a system. What system? Of course, it is your oil lubricator stern tube, right? Don't just say stern tube. Has to be more specific. It's oil lubricator stern tube with all this oil sump, oil tank, and all those things, right? Okay, so it has to be oil lubricator stern tube. I don't think there's another way of describing it. All right. Okay, name the components marked 1 to 7. Of course, there are 7 in your notes. There are more than 7 parts there in the similar diagram. So all you need to do is 1 to 7. Leave the X alone, right? Okay. So number 1, of course, is your header tank or stern tube. There's another header tank here, so you got to be very specific. Number 1 is header tank for stern tube. Number 2 is your forward seal. Know where the arrow is pointing to, right? Forward seal. If this is a forward seal, number 7 got to be your aft seal, right? So we'll come to that. Number 3 is a header tank for your aft seal. So if you already identified this header tank for the aft seal, number 7 definitely is your aft seal, right? Okay, number 3, header tank for aft seal. So there's a header tank for stern tube and header tank just for the aft seal. Number 4 is a forward bearing, the forward part of the stern tube, right? Of course, you can write in short form FWD. That's fine, right? And number 5, of course, is your sump or sump tank. And number 4 is your forward bearing. Number 6 has got to be your aft bearing, right? Aft bearing. So it's okay to write bearing as BRG. That's fine. Okay, BRG. And number 7, of course, not forgetting, is the aft seal. And that's it. Your 7 items, right? Okay. Same thing. You have done this in your weekly quiz as well, right? You have done this in your weekly quiz. Zafan said the glass gauge. You're talking about your intermediate shaft bearing, right? A gauge glass there. Glass gauge, I would advise you put it the other way around, gauge glass, right? So if you want to say glass gauge, might as well write gauge glass. I think technically that sounds better, right? Gauge glass. Okay. Okay. Now follow-up question to this, right? Stern tube system, oil lubricator stern tube system. Okay, refer to the picture in the previous slide. State the functional purpose of component 1, 7, and X. 1, 7, and X. Okay, again, we have done this in your weekly quiz. Component 1 is your header tank, right, for stern tube. And that's to create an adequate lube oil pressure to counter the effects of hydrostatic pressure of seawater outside. Okay, seawater outside. So you want the loop oil to be higher than the seawater level outside, so that the hydrostatic pressure inside the stern tube is slightly higher than the seawater hydrostatic pressure outside, so that the seawater does not go into the stern tube, have no chance to force its way into the stern tube. All right. So you can paraphrase it, but must have the same meaning. Okay. Okay, let's leave X to the last, right? So go straight to component 7. 7, you have identified aft seal already, right? So remember, if the previous component you have identified 7 as something else, then obviously you can't answer this. Okay, but you can't go wrong, right? Because you have your number 3 is your aft seal header tank. So number 7 definitely is your aft seal, right? So assuming that you have answered number 7 as aft seal. So what is aft seal for? It prevents entry of seawater and dirt into the stern tube and leakage of oil into the sea, both ways. Okay. It prevents entry of seawater and dirt into the stern tube, and it prevents the leakage of oil into the sea. So both ways. Huh? Then we come to X, of course. X that marks the spot there. So it's called a valve. You want to call it technically a bypass valve, that's technically fine as well, right? Bypass valve, that is what it really is. Technically, it's a bypass valve, but let's just call it valve. And what is it there for? Is to be open for ballast condition and closed for full draft condition. Okay, I'm not going to spend time explaining why we close for full draft and why we close for full draft and why we open for ballast. I explained that in class already, right? So valve, open for ballast condition and close for full draft condition. That's it. Okay. If you change full draft condition to full load condition, I'll give it to you as well, right? Full draft means during full load condition. But ballast condition is ballast condition, right? Just to differentiate what is the difference between ballast and full load. Ballast means the ship is floating higher up. Full load, the ship is submerged more. That's all. Okay. Right. So I hope that's clear for this particular slide. All right. Any questions, guys, so far? Okay. A couple more slides. I think that we are done. Okay. What is the type of truss block that features the inventor's name? That's the one that I've been talking about, right? Over a couple of lessons. And next sub question is use a simple sketch. Again, there's a simple sketch to explain. There's sketch and explain. Two things there. You have a sketch, and from the sketch you explain. All right. So let's answer number 1. And of course, it's your Mitchell truss block, right? That's how you call it. Right? Mitchell is the inventor's name. Right? So what is the type of truss block? Mitchell truss block. If you call it tilting pad truss block or tilting pad type, that's correct also, because this inventor invented a tilting pad truss block. Okay, so you answer saying tilting pad, fine, or just name the inventor's name, Mitchell truss block. Okay, so that's your answer there for number 1. Number 2, this is a sketch that you will need. I think it's a much simpler sketch than your crankshaft. Okay. Okay, the top part is your truss shaft, and this thing around it is your truss collar. Truss collar. Okay. So this is like looking into the truss block from the top. Okay. Or from the side, but I think easier to visualize is when you open up the cover of the truss block and you look down, this is what you see, right? The truss collar there. Of course, the truss shaft, the truss collar, you have shaft on both sides, right? Truss collar. But just for illustration's sake, just to explain the principle of lubrication here, right? Okay, and the tilting pad type, okay, of bearing. What is the principle behind? Okay, so very, very important. Make sure that you sketch this tilting pad, truss pad in the correct direction. All right. Okay. So just to make sure, right? So I think it's, I just need to do this, right? A little depression here, right? I don't like sharp corners, so I make a little radius here. And then another straight line here, another maybe not so long. A little bit of radius here, go up here, and then here, right? So this one, straight line, right? Okay. Then I'm going to do this truss collar. Okay. Truss collar will go beyond this. Okay. Go beyond this. This is a rectangular thing here. That's my truss collar. Okay. So imagine there's a center line here. Okay. And also I have my truss shaft here. So again, no sharp corners, so a little bit of radius here. Little bit of radius here. Okay. So that's my truss shaft and truss collar. Okay. And then I'm going to do this. This part is critical. Okay, the tilting pad. Okay, tilting pad. So make sure you get this triangular shape there first, then you don't go wrong. Right? So first of all, make a line there so that you have this triangular shape there. Right? This triangular shape. And then now, the trick is not to make this touch here. The trick is you know, make sure that you have this line here that goes all the way to somewhere in the center. Okay, and then this is going to a little corner here come down. This part is going to touch the bottom here. Make sure it touches the bottom here. Okay. So you can do straight line, use a ruler. Right? So this is the bottom part here. Okay. This point must touch the bottom. Okay. So it's this shape here, and here there are two thickness here. The change is at the middle, right in the middle. Not here, but right in the middle. Okay? And it's always good to give a little shading, right? Little shading there. I want to concentrate on that truss pad there. Okay? Truss collar, truss shaft, truss pad. Okay? And don't forget, I want to add in the little bit of oil wedge there. Okay, so you don't have to use different color, but you can sketch a little triangle there, right? Sketch a little triangle there. Yeah, put little dots in there. Right? That's to represent the oil film. Okay. Then you go on to label them. Okay. Of course, you must have a big arrow here. Okay. Truss. Truss from the propeller. Okay. All right. And then you have another arrow here to show you that the truss collar is rotating this way. Okay, label this as a truss collar. Right? Label this as your tilting pad. Okay, you can say tilting pad tilts. Of course, we know tilting pad it will tilt. Okay. Very, very importantly, don't forget label this oil wedge. Oil wedge. Okay. Yeah, of course, oil wedge forms. Okay, oil wedge. That's very important. Okay. So that's it. Right. I'll give you 5 minutes, right? More than enough to do this, okay? Again, practice, right? And of course, your stationary housing. This part here is your stationary housing. Right? This part here. Okay. Use a simple sketch to explain. Okay. So simple sketch. Explain. Explain is here. Oil wedge. Main thing here. All this is so that you can form an oil wedge here. Okay. This oil wedge is going to give you the loop oil that is going to go inside here. The gap is getting smaller and smaller, so that the pressure of the oil film builds up to a few hundred bar here, and it is due to this build up of oil pressure that keeps this surface of the truss collar away from the tip of this tilting pad here. Okay. And through this oil film, the whole thrust of the propeller shaft gets transmitted from the truss collar to the tilting pad. And it rests on this point here and goes into the stationary housing. And from the stationary housing, it projects downwards to the ship's structure. So the ship will move, right? And it got at least 6 of these, right? 6 of these pads. Okay. Now the question says very specifically, right? Use a simple sketch to explain. Now it doesn't say use a simple sketch and explain. Okay, use a simple sketch to explain. So this is enough, right? Sketch and label. That's all. This is called sketch to explain. Sketch and explain means you need a sketch as some paragraph there to explain, right? But here, use a simple sketch to explain. Okay? So this is good enough, right? Everything there. All right, guys. Once again, practice, practice, practice. Okay. Question? What? This is going to be the last thing I'm going to talk about, right? What are truss blocks usually? Why are truss blocks usually positioned next to the propulsion machinery? Why are truss blocks usually positioned next to the propulsion machinery, next to the main engine at the aft? So again, the question is there. The whole thing here you got to state, right? Next to the propulsion machinery, so that the effects of differential expansion of shaft and hull is reduced. Effects of differential expansion of shaft and hull. Differential expansion, the shaft stays in one dimension, the length, but the hull can expand a little bit, right, due to various stresses, due to temperature, expansion, contraction, right? And the effects of whirl of tail shaft or droop due to propeller weight and movement of the hull are mitigated, right? Mitigated means you have less effects of whirling effect of the tail shaft. I explained, right? Tail shaft whirling when you have a very heavy propeller, 80 tons propeller here, trying to bend the tail shaft this way, the forward end of the tail shaft will have a tendency to do this, right? So that's called whirling. So you're not going to put the truss block near there. The truss block is going to get damaged. So you got to position a truss block further away from that, right? From the end of the tail shaft there. So in order to position far away, you got to be nearer to the engine. Okay. Okay, and you want to make use of the third point. Make use of the heavy construction of the double bottom structure under the main propulsion machinery, so that it gives the ideal foundation. It's a more solid foundation for the forces to be directed downwards, right? Because underneath the main engine, the double bottom structure is the most rigid part of the ship. Because the whole engine that is maybe about 20 meters long, right? So across that 20 meters, the the whole bottom double bottom structure got to be very, very rigid, because any flexing there, the engine can get damaged, right? So you want more stiffness inside the double bottom there under the main engine. So by being close to the main engine, that section there is also quite rigid, right? And you probably have additional stiffening under the double bottom there, also extended a little bit, so that your truss block can direct the truss force to the ship's hull, so that your truss block sits on a very, very solid foundation. Okay, so those 3 points there, right? Why truss block must be located next to the propulsion machinery. Okay. Right. Questions? Anything that you like to ask? Anything that you wish to have talked about? Anything else? Because this is the last slide I'm going to talk about, guys. Okay, we started a little bit later than usual because there were some confusion there. Some cannot log in, some can't see me, cannot hear me, all those things. Okay. Okay, guys. Really, question? Anyone? Okay, I'm going to be here for the next couple of minutes in any way, in any case. So if anyone has any question in the next couple of minutes, otherwise, yeah, I'm stuck again here in my slide. Hang on. Okay, otherwise, I think you guys got it, right? Okay, and you guys definitely can do it if you'll be following me all the while, right? So give it your best shot, guys, right? And all the best for your exams, right? Of course, go for it, right? Go for the highest marks possible. Okay, so those who do not have any question, that's it, right, guys? That's it for today, and all the best, right? And yeah, Hui Shen here, has a question. Compile the previous MCQ quizzes together. Compile. I've been sending you weekly emails. I mean, I do not know what it means by compile. All the weekly emails, MCQs, or not MCQ, all the weekly quizzes with answers I've been sending to you guys every week. Of course, the latest one, steering gear, I'll be sending out, maybe the next couple of days, right? Hopefully you have done the steering gear one as well. I'll send out the steering gear. I will not go through the steering gear quizzes answer. So I will send you the answer straight away, right? Okay. So Owen say class on Thursday. Well, you have read my email, right? Hope you have read my emails already, right? No plans. No plans for tutorial this week unless you guys request for it, right? Okay, so that's it. This has been my last time the last time you hear from me, right? The last time you see me live, no more live session, right? Until probably you're going to see, no more live meetup until your exam. Of course, I'll be making my short rounds during your exam for this module, right? Okay, guys. Anything else? Otherwise, that's it. All the best, and go for it, right? Do your very best. Nobody should fail, remember? Okay, guys. Okay, make use of your supposedly tutorial lessons this week wisely, right? Do your self-study, use it wisely. Owen is asking slides. Can we access? You mean the slides today? Okay, those of you are still tuning in, I think good news is that I plan to send you this slides, but no narration, right? I'm not recording anything. Okay, guys, anything else? I say I'll stick around here for 1-2 minutes. Yeah, that's it, right? Otherwise, we can leave this session anytime. Okay, right, go for it.